Hello, this is Dr. Henry, and we are looking at another stoichiometry problem. It might be best if perhaps you pause this and try to do the problem on your own and then watch the video. That's probably the best way to learn how to do this. So let's read the problem first. So we have 0.75 grams of nitrogen monoxide reacts with excess hydrogen. Determine the percent yield of nitrogen if the actual yield of nitrogen is 0.29 grams. So we are given, and let me get my pen here, sorry. So we have 0.75 grams of nitrogen monoxide. We have an actual yield of nitrogen of 0.29 grams, and we want to find percent yield. All right. So what's the formula for percent yield? Well, percent yield is the actual yield divided by the theoretical times 100%. Okay? So we know that, we know that the actual yield is 0.29 grams. So to find the percent yield, we got to figure out this. We got to find the theoretical yield of nitrogen. All right? And what are we starting with? Well, we're starting with 0.75 grams of nitrogen monoxide. So we need to convert that to grams of nitrogen. So this is going to be a gram to gram problem. So remember, you're going to start with grams given, and then we're going to need to convert that to moles of given. And then we're going to go to our moles wanted, and then convert that to grams wanted. All right? And so this is our game plan. This is what you need to know. And to go from grams given to moles given, we're going to have to use the molar mass of the given. To go from moles given to moles wanted, that's where we use the coefficients. And then to go from moles wanted to grams wanted, we're going to have to use the molar mass of what we want. So let's set this problem up. So let's do our first fence post. So we're starting with 0.75 grams of nitrogen monoxide. No, spells no, okay? So if we start with grams of nitrogen monoxide, we have grams of nitrogen monoxide down on the bottom. Nitrogen monoxide is commonly called nitrous oxide. And then we want to go to moles of nitrogen monoxide. That's on front. And for our conversion, 1 mole of nitrogen monoxide, we have 1 nitrogen, which is 14.01, plus 1 oxygen, which is 16. So we have a mass of 30.01 grams of nitrogen monoxide. So this is going to take us from here to here. Next, we want to go from our moles given, which is nitrogen monoxide, to what we want. And we want grams of nitrogen, but we got to go through moles of nitrogen first. So moles of nitrogen monoxide's here. So we put moles of nitrogen monoxide down here. And then we want moles of nitrogen, so that goes up top. And this is where, when we're going from mole to mole, we use the coefficient. So we look up here in the equation. So nitrous oxide has a coefficient of 2. We look over here. There's nothing written in front of nitrogen, so it's understood to be 1. All right, so if we stopped here, our answer would be moles of nitrogen. But we want grams of nitrogen, so we got one more step to do. So we add another fence post, and then we put moles of nitrogen on the bottom, And whatever you want to end up with goes on top. So grams of nitrogen goes here. So we put a 1 here. 2 nitrogens is 28.02. All right, so we have, oops, why is this not working? Equals, let me get my calculator here. So we have 0.75 times 1 times 1 times 28.02 equals 21.015 divided by 30.01 times 2 times 1 equals 60.02. So 21.015 divided by 60.02 equals 0.35 grams of nitrogen. All right, now we got to find the percent yield. So the percent yield equals the actual yield, which we were told was 0.29 grams of nitrogen, divided by our theoretical yield, which is 0.35 grams of nitrogen times 100%. And so that equals 0.29 divided by 0.35 times 100 equals 83% yield. So this asks for percent yield. So we needed to find the theoretical yield in grams, and then we use this to find the percent yield for that problem. Thank you.